Hello. Even though the title of this video is Similar Triangles and the Sine Ratio, what we're actually going to be talking about is an application of proportions. Because similarity in refers to proportionality, and the sine ratio is also an application of proportion. So in order to set this up, I'm going to construct two similar triangles. Similarity in mathematics means shapes are the same in terms of the angles and the proportions, but the sizes may be different. So think of it as you've got two of the same shape, but one is smaller than the other, or larger than the other. All right, so I'm going to make two right triangles that are similar. And the way that I'm going to make sure that they're similar is I'm going to draw them one on top of the other. So my first right triangle is right there. And the second one is going to be, you can imagine, overlapping. Like this. So these would be considered similar triangles because they both have an acute angle down on this left-hand side that is the same size. They both have a right angle, and they both have this third angle, which is also acute, but those are the same size. I'm going to provide a little bit more information in order to help with the demonstration. So for the smaller of the two, I'm going to say that this height is equal to 5 centimeters, and the hypotenuse, or the side that's opposite this 90-degree angle, is 10. So the relationship between the shorter leg and the hypotenuse, you can see that the hypotenuse is double. Well, the larger of the two triangles, its height is 10. So based on that proportionality of the hypotenuse being double 10 is 20. So from that, I can write a proportion. And a proportion is essentially a fraction that is equal to another fraction. So in this case, I would be comparing the height and the hypotenuse of the small triangle to the height and the hypotenuse of the large triangle. So 5 over 10 and 10 over 20. Which if I simplify by actually doing the division 5 divided by 10 and 10 divided by 20, that will boil down to 0.5 and 0.5. So from there, it brings me to the sine ratio. The sine ratio is a comparison of an angle, call it theta. Theta, the symbol theta, is a letter, a Greek letter, and it is often used to represent an angle. So sine theta describes the relationship between the side opposite that angle and the hypotenuse. Which we've already set. The side opposite over the hypotenuse is 0.5. So for this example, sine theta for both triangles is 0.5. And if I was being asked in a problem to find what is the actual measure of theta in degrees, I'm going to need to use my calculator to find what angle generates a sine value of 0.5. So in order to accomplish that, I'm going to use second function, sine. So to find theta, I'm going to do arc sine, it's called, 0.5. And it depends on which calculator you're using. You have to learn how to find that second function. But for me, arc sine is written in orange here, right above the sine button. So I'm going to go second function, sine, you can see that at the top there, of 0.5 equals 30. So that means that in my triangles that I've drawn, the theta value is 30 degrees down in this corner. So for both of those triangles, they had a 90-degree angle on the bottom right. They have a 30-degree angle on the bottom left. And I can use a little bit of arithmetic to find that the third angle up in the top right is 60 degrees, because all of the angles together has to add up to 180